Hello there, and welcome to this sleepy universe zone. Tonight, we're going to explore something utterly fascinating, quietly terrifying, and deeply relaxing all at once: the true darkness of space. Imagine staring into a void so complete, so absolute, that even your own hand, stretched in front of your face, vanishes. Not the darkness of your bedroom, not the shadowed corners of a cave, but a darkness that no eye has evolved to fully comprehend. This is the reality beyond our atmosphere, a darkness so profound that light itself seems powerless to reach you. And tonight, you'll understand why space is darker than anything you could imagine, and why that darkness is not just an absence, it's a story of the universe itself. If you enjoy unraveling the quiet mysteries of the cosmos while letting your mind drift, consider giving this video a like. It's a small gesture that helps more curious minds discover this journey, and it gently nudges your own brain to stay engaged as we dive deeper. Let's start where you are, on Earth. You might think you know darkness. Perhaps you've sat in a room at midnight with all lights off, or closed your eyes, believing yourself enveloped in total black. But even in the darkest room, your eyes are still receiving light. The soft glow of the moon, distant streetlights, the faint shine of cities miles away. Rod cells in your retina adapt, your pupils dilate, and your brain begins filling in the gaps, constructing detail, contrast, and depth. What feels like darkness is already patterned, already alive with faint light. Now, imagine leaving this bubble entirely. Astronauts venturing beyond Earth's protective atmosphere describe something unlike anything on our planet. Bruce McCandless II, the first astronaut to perform an untethered spacewalk in 1984, recalled a darkness so deep it felt almost physical. He could not see his own hand. The spacecraft itself faded into absolute black, and the usual cues of up and down disappeared. Your senses evolved over millions of years to catch the faintest glimmers of light, are suddenly rendered nearly useless. Why does this happen? In the stretches between stars, the universe is almost entirely empty, roughly 1 atom per cubic centimeter. Beyond galaxies, in the intergalactic void, the density drops to 1 atom per cubic meter. Light is everywhere, streaming from stars, galaxies, and the cosmic microwave background, but unless it interacts with matter, it remains invisible. Darkness, then, is not the absence of light. It is the absence of light reaching your eyes. Even photons traveling at 186,000 miles per second pass through these vacuums, unnoticed, unseen, unless they hit an object or your retina. Out there, light from billions of stars might brush past you, and yet you would perceive nothing. Your brain, craving input, faces a void it cannot interpret, a blackness with no reference, scale, or texture. In this chapter alone, you've glimpsed the paradox: a universe teeming with light and energy, yet appearing overwhelmingly dark. The silence, the emptiness, the absolute absence of visible matter is profound, but it's also strangely relaxing, like a cosmic meditation. As we continue to explore this darkness, you'll discover its effects on human perception, its psychological echoes, and the subtle ways it teaches us about the scale and structure of the universe. Out there, in the inky black beyond stars and planets, the universe is vast, indifferent, and unimaginably quiet. It's a darkness that challenges our senses, our minds, and even our sense of place. But it's also a darkness that invites contemplation, wonder, and a gentle, sleepy awe. You might think the night sky you see from your backyard is the ultimate darkness, but it's only an introduction. Out here, beyond the protective blanket of Earth's atmosphere, darkness becomes a different kind of reality, one that doesn't just hide things from your eyes, but seems to erase them entirely. Consider this: Even the faint glow of distant stars, which fills the night sky with patterns we recognize, becomes meaningless in space. Astronauts report that once you look away from illuminated objects like Earth or the Sun, your brain confronts something it cannot predict, a void that stretches in every direction, utterly empty. The stars that once seemed so numerous and comforting shrink to mere points of light, distant and insignificant, offering no sense of depth, no cues for up or down. For anyone watching this, yes, you, the person who's ever stared into the night and wondered what lies beyond, this is your window into that silent emptiness. You will understand why the darkness you feel in a cave or a power outage pales in comparison, and why the void of interstellar space can affect both body and mind in ways you cannot anticipate. Why is it so different? On Earth, even the darkest places are alive with photons. Moonlight, scattered starlight, faint air glow, and residual artificial light all reach your eyes. Your visual system evolved to detect these subtle signals. But in the vacuum between stars, light has nothing to bounce off. It travels endlessly until it meets matter. Otherwise, it is invisible. In that sense, space is not just dark. It is a stage on which light itself can vanish. Imagine floating in a spacecraft halfway between the nearest stars. The sun, your once dominant source of warmth and illumination, has become a faint dot. The nearest star is light years away, reduced to a glimmer so dim that it provides no orientation, no illumination. In every other direction, darkness dominates, stretching over trillions of miles with nothing to interrupt it. Your eyes, capable of detecting individual photons, receive nothing. Your brain, starved of input, struggles to create meaning. Astronauts describe this as both disorienting and strangely hypnotic. The absence of visual cues removes familiar anchors, the ground beneath, the horizon, the sky above, and replaces them with a sensory blankness. Your inner sense of position, proprioception, becomes primary. You can move your arms and legs, feel your body, but there is no reference outside yourself. You are isolated in a void, surrounded by a darkness so complete that the concept of seeing feels meaningless. This emptiness isn't just a quirk of distance, it's a feature of the cosmos. Stars, planets, and galaxies are concentrated in islands of matter separated by incomprehensible voids. The vast stretches between them are nearly perfect vacuums. And within these vacuums, photons fly unhindered, mostly unseen, a universe full of energy, yet appearing utterly black. Even at the scale of galaxies, this emptiness persists. The space between the Milky Way and Andromeda, our nearest large galactic neighbor, is approximately 2.5 million light-years. Between them lies darkness, more absolute than anything on Earth, a region with less than a single atom per cubic meter. If you were there, you would see two faint spirals of light, the galaxies themselves. But beyond that, infinity stretches in complete blackness. The contrast is staggering, islands of structure floating in a sea of nothing. For those of you listening, consider what this means psychologically. Humans evolved in an environment rich with sensory input, light, sound, touch. The sudden removal of visual cues triggers a state that can be meditative or unsettling. Extended exposure to this void would likely cause your mind to generate its own imagery, hallucinations born from the absence of external signals. Yet in that creation, there is also wonder. In that emptiness, you begin to perceive the universe not just with your eyes, but with your imagination, with your mind reaching out to fill the void. The darkness of interstellar space is absolute, yes, but it is also instructive. It teaches us about scale, about the distribution of matter, about how light behaves across unimaginable distances. It shows us that the universe is not a crowded stage, but a sparse arena where structures exist precisely because vast emptiness separates them. And in understanding this, we find a calm, almost sleepy awe, a reminder of how small we are, and yet how capable of understanding the grandest scales of existence. Out in the vastness of interstellar space, darkness does more than blind. It transforms the way the brain perceives reality. Astronauts on long-duration missions consistently describe a phenomenon that cannot be replicated on Earth, a cognitive stretching where your mind struggles to interpret nothingness. Imagine staring at a window of your spacecraft, far from the sun and any nearby planets. You see only black, interrupted by faint stars that provide no spatial cues. Your eyes, primed over millions of years to detect even the faintest photons, receive no input. The visual cortex, the part of your brain that constructs reality from light, goes quiet, starved of signals. In such conditions, research in sensory deprivation suggests the brain begins creating its own imagery. Hallucinations are common. Flashes of color, geometric patterns, even entire imagined landscapes. For listeners, this is not just a story of extreme isolation. It's a window into human perception. On Earth, studies of sensory deprivation tanks show that even brief exposure to complete darkness triggers visual cortex activity in the absence of external stimuli. Your mind invents what it cannot see. In space, where the void stretches for light years, the effect magnifies. Your brain, desperate for reference, fabricates light and structure in a world where none exists. It's not only visual. The absence of sound in the vacuum amplifies the psychological effects. No air to carry noise, no vibration to give context, just silence. Astronauts describe a heightened awareness of their own bodies, a hyperconsciousness of each heartbeat and breath. In combination with the visual void, the experience can feel profoundly isolating, or, for some, strangely meditative. These effects illustrate a broader truth. Darkness in space is not merely physical. It is an environment that challenges human cognition, revealing the flexibility and fragility of perception. Out there, your mind learns to exist without familiar anchors, and in the process, discovers a strange, sleepy awareness of scale, absence, and cosmic solitude. Step back and consider distance on a cosmic scale. From Earth, the nearest star after our Sun, Proxima Centauri, lies 4.24 light-years away. That's about 25 trillion miles. So far that light from Proxima takes over 4 years to reach us. If you were floating halfway to it, neither star would illuminate your surroundings significantly. You would be engulfed in darkness that is both absolute and overwhelming. For anyone listening right now, imagine yourself suspended in that void. No horizon, no familiar objects, no points of reference except the faint pinpricks of distant suns. Even the Milky Way, so crowded with stars from Earth's perspective, would appear as a soft, indistinct glow, its intricate detail lost at such distances. Space on these scales is sparsely populated. The average distance between stars in our galactic neighborhood is around 5 light-years, a gap so vast that if Earth were the size of a grain of sand, the nearest star would be another grain floating kilometers away. The perception of a full night sky is an illusion, created by the limits of human vision and the filtering effect of our atmosphere. This emptiness is crucial. It allows galaxies, stars, and planets to exist without immediately colliding. It defines the structure of the cosmos. But for a human observer, it is psychologically profound. There are no reference points, no familiar context. The void seems infinite. The brain, trained to navigate a world full of surfaces, edges, and light, encounters something fundamentally alien, a scale too vast to comprehend, and a darkness too absolute to interpret. In these stretches of interstellar space, the mind oscillates between awe and discomfort. Alone in this sea of nothing, the cosmos forces you to confront the fundamental truths of your existence. And yet, paradoxically, it can also produce a gentle, sleepy reverence, a quiet recognition of how extraordinary it is to simply perceive this emptiness, even from the relative safety of a spacecraft. Even though space is filled with light, it remains overwhelmingly dark. This seems paradoxical, but it comes down to one fundamental truth. Light is only visible when it interacts with matter. Photons, the particles of light, stream across the cosmos at 186,000 miles per second. But unless they hit something, they are invisible. For you watching this, consider the implications. On Earth, we see light because it reflects off surfaces, walls, floors, air particles, even dust. Sunlight scatters in the atmosphere, illuminating everything around us. In space, there is nothing to scatter light. Even when billions of photons pass by your eyes, if they don't strike an object or enter your retina directly, your brain perceives nothing. Darkness is not the absence of light. It is the absence of light reaching you. Astronauts describe this effect vividly. When looking away from the sun and Earth during a spacewalk, their helmets reveal only blackness. Tools, hands, even the spacecraft itself can vanish instantly into the void if not illuminated. The sun, while bright, casts light only along straight lines. Beyond those lines, nothing glows. Shadowed areas in space are not dim, they are absolute. This principle has profound implications for exploration. Spacecraft must carry artificial lights for any work outside or in shadowed areas. Instruments detect photons across wavelengths invisible to the human eye, infrared, ultraviolet, X-rays. But your perception remains confined to a narrow slice of the electromagnetic spectrum. To our eyes, the universe is mostly black, punctuated by bright, distant points of light. Let's expand our perspective further. The space between galaxies is even emptier than the gaps between stars. For instance, the Milky Way and Andromeda, our nearest large galactic neighbor, are separated by roughly 2.5 million light-years. Between them lies intergalactic space, a vacuum so sparse it contains about 1 atom per cubic meter. This is emptiness on a scale our minds struggle to comprehend. Imagine being suspended there. You would see Andromeda as a faint spiral, distant and almost ghostly, and the Milky Way as another subtle glow. In every other direction, blackness, absolute darkness stretching millions of light years. The sheer scale is disorienting. No horizon, no reference, no familiar objects. The mind, craving context, faces a canvas of pure void. This emptiness is not only physical, it is psychological. Humans evolved to navigate cluttered, illuminated environments. In these voids, your senses confront a reality they were never designed for. Prolonged exposure can evoke a profound sense of solitude, even existential reflection. Yet there is also serenity here, a quiet, almost hypnotic calm, where the mind can drift freely and imagination fills the unlit spaces with wonder. Understanding this, we see why darkness is the dominant feature of the cosmos. Light exists, but it is rare, concentrated in stars, galaxies, and energetic phenomena. Most of the universe is empty, silent, and still. For explorers, both human and robotic, this reality dictates every challenge, navigation, perception, and even the psychological endurance needed to exist within it. Out here, the void is not hostile, it is indifferent. Yet in its indifference lies beauty, a clarity of scale, a meditation on existence, and the quiet knowledge that even in vast emptiness, we are capable of perception, exploration, and understanding. Imagine standing on the far side of the moon, looking out into the void. No Earth to provide color, no sun to scatter light beyond the harsh shadows, just darkness stretching in every direction. For astronauts, this experience is not only visual, it is profoundly psychological. During the Apollo 8 mission in 1968, astronauts Frank Borman, Jim Lovell, and William Anders orbited the moon and lost contact with Earth for about 45 minutes. Out there, behind the moon, the Earth was completely hidden. They saw only lunar terrain bathed in sunlight on one side and absolute black on the other. Stars twinkled faintly, but without reference points. They seemed untethered, close and infinitely distant at the same time. This is the kind of emptiness humans were never evolved to experience. Our brains expect cues. Light bouncing off surfaces, shadows revealing shapes, nearby objects for scale. In their absence, the mind is left to process nothing. Some astronauts describe a sense of isolation, a quiet unease. Others find it meditative, a chance to contemplate the scale of the cosmos and their own smallness within it. For anyone watching, this is where curiosity meets introspection. Being confronted with darkness on this scale forces the question, how does one reconcile with emptiness? Humans rely heavily on visual input for orientation, emotion, and cognition. In its absence, even the simplest tasks, grasping a tool, navigating a spacecraft, require complete reliance on training, instruments, and trust in yourself and your team. Beyond perception, darkness in space also reshapes neural processing. Research on sensory deprivation and astronaut reports suggest that when visual input is drastically reduced, the brain reorganizes itself. Neurons in the visual cortex, starved of signals, begin responding to other sensory information, sound, touch, even internal signals. For long-duration missions, this adaptation is crucial. Astronauts on the ISS experience 16 sunrises and sunsets per Earth day, yet still require carefully managed lighting to maintain circadian rhythms. Without artificial light, extended periods of visual void could lead to hallucinations, distorted time perception, and cognitive strain. The brain, deprived of the usual cues, invents its own patterns to compensate. This is why spacecraft design includes more than just life support. Windows, lighting, and interior color schemes are meticulously planned to simulate familiar cycles, provide reference points, and protect mental health. The absolute darkness outside isn't eliminated, it is embraced, but humans are equipped to survive within it. For viewers, this illustrates a fundamental truth. Space's darkness is both external and internal. It exists in the void of photons and in the rewiring of your mind. It challenges perception, cognition, and emotional stability, but it also provides a unique environment for contemplation, introspection, and even relaxation. In the cosmic night, the mind learns to float freely, to drift in silence, and to find peace in absolute emptiness. Even in the darkness of interstellar space, light exists, though mostly in forms invisible to the human eye. The universe is filled with photons, traveling across vast distances at unimaginable speeds. Yet for an observer adrift in the void, much of it remains imperceptible. The stars we see from Earth are only a fraction of the photons surrounding us, and the rest, infrared, ultraviolet, X-rays, and microwave radiation, passes through empty space unnoticed by our senses. Imagine floating in the expanse between star systems. You might see a distant sun reduced to a tiny point of light, but billions of photons from countless sources are streaming past you, invisible, unperceived, untouched by your eyes. The cosmic microwave background, the faint afterglow of the Big Bang, suffuses space with a low-level radiation that would be warm if our bodies could sense it directly. Yet to our vision, the darkness is absolute. Astronauts venturing outside the confines of spacecraft encounter this directly. Even when the sun illuminates a part of their surroundings, shadows become blacker than any earthly night. A hand extended into the shadow can disappear entirely. Tools and objects vanish into nothingness unless lit by artificial light. It's not just absence, it is a disappearance of expectation. Our brains evolved to detect subtle differences in shade, to extract meaning from dim illumination. In space, that mechanism is denied. This creates an unusual psychological effect. The mind seeks patterns, even inventing them. Astronauts report fleeting visions, minor hallucinations, or sudden awareness of the infinite, a floating consciousness that is acutely aware of its isolation. The phenomenon mirrors research on sensory deprivation, where the brain, lacking input, begins producing its own stimuli. In the absolute darkness of space, this effect is amplified to a cosmic scale. Curiously, not all light is absent. Some photons do strike dust, gas, or spacecraft surfaces, revealing faint glows and subtle details. For example, astronauts have described seeing the faint zodiacal light, the sunlight reflected by cosmic dust in the solar system, stretching like a ghostly ribbon across the void. These rare photons become precious beacons, tiny markers in a sea of emptiness. They remind the observer of structure, of orientation, and even of time. The paradox is fascinating. The universe is awash in light, yet darkness dominates perception. This teaches a subtle lesson about human awareness. We experience reality not as it exists objectively, but as our senses and brain interpret it. Space is not dark in a literal sense. It is largely empty of surfaces for light to interact with. It is a medium where photons travel without interruption, unseen until they meet matter. Our perception is limited, and in that limitation, the void feels profound, silent, and absolute. For those watching this, imagine letting your mind drift into that space. Feel the quiet, the emptiness, the contrast between the few photons that reach your eyes and the overwhelming sea of invisible light passing unobserved. This is the rhythm of the cosmic night, a combination of absence, subtle illumination, and infinite scale. It is terrifying in concept, but strangely relaxing in contemplation. As you breathe, consider that each photon you cannot see is a story traveling across billions of years, a message from a distant past. The darkness is not truly empty. It is full of history, of energy, of the slow march of the cosmos. And while our eyes cannot perceive it, our minds can meditate upon it, drifting peacefully through the silent, invisible currents of space. Beyond the clusters of stars and the familiar swirls of our Milky Way lies a darkness more absolute than any night on Earth, the intergalactic void. Here, between galaxies, emptiness dominates. The Milky Way and Andromeda, our nearest large neighbors, are separated by roughly 2.5 million light-years, an unfathomable distance across which almost nothing exists. If you were suspended midway between them, both galaxies would appear as faint smudges, soft glows against an ocean of black that stretches in every direction. For anyone imagining themselves there, it is both terrifying and hypnotic. No horizon, no reference, no familiar objects to anchor perception, just silence, cold, and the infinite black. Our brains, accustomed to environments where light reflects off surfaces and objects fill space, are unprepared for this. In the absence of sensory cues, the mind begins constructing meaning, inventing patterns, or simply surrendering to the emptiness. The psychological effect is profound. Astronauts describe a combination of awe, vertigo, and a deep contemplative calm. This is not an abstract idea. The density of matter in intergalactic space is about 1 atom per cubic meter, far sparser than even the near-empty expanses between stars, which contain roughly 1 atom per cubic centimeter. In practical terms, it is almost nothing. Light travels freely through this void, yet there is almost nothing to scatter it. You would be surrounded by photons from billions of stars, and yet perceive complete darkness in every direction, except where a galaxy or star happens to pierce the void. Astronauts and astrophysicists alike point to the subtle phenomena that occasionally reveal the structure of this emptiness. Faint cosmic background radiation, the ghostly glow of distant galaxies, or the delicate streaks of intergalactic gas caught in telescope lenses are the only hints that the void is not entirely empty. To the human eye, though, it remains incomprehensibly dark, a true night without end. For viewers, imagine the contrast. On Earth, even in the most remote deserts, the Milky Way stretches across the sky, and airglow or starlight scatters photons to your retina. In the intergalactic void, the same eyes would perceive nothing. You would be floating in a vacuum where the familiar rhythm of light and shadow is absent, and time itself feels suspended. There is no up, no down, no near, no far, only a sense of infinite distance in every direction. Yet this emptiness is also meditative. In its silence, there is space for thought, for reflection, for a slow, sleepy awareness of scale. The mind, freed from constant visual cues, begins to appreciate the extraordinary vastness of the cosmos, the delicate islands of light that define galaxies, and the staggering emptiness between them. It is a darkness that is not hostile, merely indifferent, but that indifference itself invites contemplation. This intergalactic void teaches a subtle lesson about human perception and cosmic reality. The universe is structured not to fill every corner with light or matter, but to allow patterns to emerge precisely because emptiness dominates. And while our senses struggle with this emptiness, our minds can find tranquility, floating peacefully through the silent, eternal darkness that stretches between galaxies. In the vast emptiness between galaxies, the human sensory system faces a challenge it was never designed to encounter. Without surfaces for light to bounce off, without air to carry sound, and without familiar reference points, the brain receives minimal input. The result is a profound form of sensory deprivation that can alter perception, cognition, and emotional state. Astronauts report that when gazing into the void, their minds begin filling in the gaps. Patterns appear where none exist, shapes emerge from nothing, and the sense of time can distort. Research on isolation and sensory deprivation chambers on Earth mirrors this effect. In the absence of visual and auditory stimuli, the brain creates its own input. Hallucinations, geometric patterns, and imagined landscapes are common. In space, these effects are amplified across a scale our brains struggle to comprehend. The visual cortex, accustomed to processing photons, is starved in intergalactic darkness. In response, it recruits other sensory regions, heightening awareness of touch, proprioception, and internal bodily signals. Astronauts describe an acute perception of their own movements, the faint hum of life support systems, and the vibration of machinery. Every sensory cue becomes amplified, while the absence of light creates an encompassing, meditative quiet. This extreme environment also challenges circadian rhythms. Without the sun's predictable cycles, internal clocks can drift. On the International Space Station, astronauts rely on artificial lighting and structured schedules to maintain physiological and psychological health. In deep space, far from any natural light, These interventions become essential to prevent disorientation, sleep disorders, and cognitive fatigue. Yet there is a paradoxical beauty in this deprivation. Freed from constant stimulation, the mind can wander, explore, and contemplate the vastness surrounding it. The emptiness of the universe, the absence of familiar cues, allows for a unique mental state, quiet, reflective, and surprisingly relaxing. The cosmic void, while indifferent and absolute, provides space for the human mind to expand inward, even as it floats amidst the infinite. This experience is not merely theoretical. Astronauts on long-duration missions consistently report that looking into deep space evokes a mix of awe, humility, and tranquility. The darkness challenges perception, but it also cultivates introspection. In the absence of familiar light and sound, consciousness stretches, finding patterns in emptiness and serenity in the infinite, absolute black of the cosmos. The intergalactic void teaches a profound lesson. Perception is relative, and emptiness can be both disorienting and calming. The universe, vast and indifferent, imposes its scale on the observer, yet within that scale, the mind finds space to breathe, to reflect, and to experience a sleepy, meditative awe, unlike anything on Earth. Even in the absolute void between galaxies, darkness is not truly empty. At the quantum level, the universe hums with activity imperceptible to our senses. Space is filled with quantum fluctuations, virtual particles that briefly pop into existence before annihilating each other. These fluctuations occur everywhere, even in regions that appear completely dark, creating a subtle, unseen energy that permeates the cosmos. This phenomenon, known as vacuum energy or zero-point energy, is a reminder that our perception is limited. The darkness we experience with our eyes is only a tiny fraction of reality. While photons may not reach us and visible matter may be absent, the quantum field is alive with continuous motion. Particle-antiparticle pairs flicker in and out of existence billions of times per second, producing an invisible, restless foundation underlying the apparent void. Astronomers and physicists speculate that this vacuum energy may relate to dark energy, the mysterious force driving the universe's accelerated expansion. In that sense, the darkness is not merely empty, it is dynamic, containing the seeds of cosmic evolution itself. Although we cannot see or feel it, the universe is teeming with subtle activity, quietly shaping the large-scale structure and fate of galaxies, stars, and planets. For humans observing from a spacecraft, this has intriguing implications. Your eyes see blackness, your mind perceives emptiness, yet beyond your senses, reality is vibrant with motion at scales far smaller than you can detect. This disparity creates a subtle tension. The universe is silent and dark to you, but underneath lies a quantum ballet invisible and constant. It is a cosmic whisper, a hidden pulse beneath the stillness. Understanding this requires a shift in perspective. Darkness is not absence, it is invisibility, a limitation of perception, and a canvas for both imagination and scientific inquiry. Every photon that never reaches your retina, every virtual particle that flickers unseen, is a testament to the richness of the cosmos. Even in what appears empty, there is structure, energy, and profound complexity. This quantum perspective also deepens the psychological experience of space. Astronauts report that the more they contemplate the void, the more they perceive its scale, not just physically, but existentially. The infinite black around them mirrors the invisible motions beneath, producing a sense of awe, humility, and paradoxically, a meditative calm. Darkness, even absolute darkness, is alive in ways our senses cannot detect. As you imagine drifting through intergalactic space, consider this. Each seemingly empty cubic meter is a theater of quantum activity, a stage where reality flickers, disappears, and reappears billions of times per second. To our eyes, it is still black. To our minds, it is endlessly fascinating. The universe teaches that emptiness is not nothing. It is a subtle, hidden fullness, a profound layer beneath the silence of space. Beyond the stars, beyond the intergalactic void, there exists a vast, unseen component of the cosmos, dark matter. It makes up roughly 27% of the universe's total mass energy content. Yet it neither emits, absorbs, nor reflects light at any wavelength detectable by human eyes. In essence, it is invisible, only inferred through its gravitational effects on visible matter. Imagine drifting through a galaxy. You see stars, nebulae, and the faint glow of cosmic dust, but most of the mass surrounding you is imperceptible. Dark matter forms a vast scaffold, shaping galaxies, dictating their rotation curves and influencing the clustering of galaxy clusters. Without it, the spiral arms of galaxies would fly apart, and the large-scale structure of the universe would collapse. For observers in space, this creates an unsettling reality. The universe we perceive is only a small fraction of what actually exists. Out there, the darkness you see is punctuated by islands of light, but the majority of matter is hidden in plain sight, moving silently through the cosmic void. It is a shadow universe, vast and real, yet completely inaccessible to our direct perception. Astronomers detect dark matter indirectly through gravitational lensing, the motions of stars and galaxies, and large-scale cosmological simulations. These observations reveal that the universe is structured not just by the luminous matter we see, but by a hidden web of dark matter that holds it together. It is a ghostly framework, invisible but critical, a reminder that what we perceive is always limited by our senses. The psychological effect of this invisible universe is subtle but profound. Humans evolved to navigate environments illuminated by light, rich in sensory feedback. In deep space, even with the visible Milky Way or distant stars, most of what exists is hidden. Our perception of emptiness is therefore incomplete. The darkness we experience is both literal and metaphorical, a curtain hiding the majority of the cosmos. This unseen matter also adds a layer of existential reflection. Floating in space, surrounded by stars, yet knowing that most of the mass is invisible, one is confronted with a profound humility. The universe is vast, structured, and active, yet our senses only capture a small fraction. The cosmic darkness is not simply emptiness. It is an invitation to consider the limits of perception, the vast hidden structures, and the subtle complexities that govern everything we observe. In contemplating dark matter, we recognize that the universe is far stranger than it appears. The light we see is just the surface of a far richer reality. The void is not empty. It is full of hidden mass, silent motion, and invisible scaffolding that gives form to the cosmos. The darkness teaches us patience, curiosity, and a quiet sense of awe. Beyond dark matter lies an even more mysterious presence shaping the universe, dark energy. Accounting for roughly 68% of the universe's total mass energy, dark energy drives the accelerated expansion of space itself, pushing galaxies ever farther apart. Unlike dark matter, it does not clump or interact with gravity in the usual way. It is a force both invisible and pervasive, stretching the cosmic void and deepening the darkness between galaxies. Imagine floating in the intergalactic expanse, far from any star or galaxy. The emptiness stretches endlessly, and the space around you is expanding imperceptibly, but inexorably. Galaxies drift away from one another, their light increasingly redshifted, eventually slipping beyond visibility. The darkness here is absolute, yet dynamic, a canvas of stillness being subtly and relentlessly pulled apart by a force we cannot see. For anyone observing from a spacecraft or imagining the void, this introduces a sense of both awe and unease. The emptiness is not static. It is alive with motion on a scale that defies human intuition. Light that reaches you today from distant galaxies may never reach you tomorrow as the expansion accelerates. Over billions of years, the universe will appear darker and more isolated, with familiar galaxies fading into a black, silent horizon. Astronomers detect dark energy indirectly by observing the redshift of galaxies and measuring the rate of cosmic expansion. Its presence is inferred from the accelerated movement of matter, the stretching of space, and subtle imprints on the cosmic microwave background. Dark energy is both omnipresent and elusive, shaping the fate of the universe while remaining undetectable to our direct senses. The psychological and philosophical impact of this cosmic force is profound. Floating in such a void, humans are confronted not only with emptiness, but with an expanding emptiness. It amplifies the sense of isolation, the scale of the unknown, and the fragility of our own existence. The stars we rely on for orientation and light will one day drift so far apart that they vanish entirely from view. Yet within this darkness, there is a quiet, meditative perspective. The universe's expansion, driven by dark energy, reveals the impermanence of even the grandest structures. It teaches patience, perspective, and acceptance of the sublime vastness. The void is not threatening, it is indifferent. But in that indifference lies an invitation to observe, to reflect, and to find a calm understanding of our place in the ever-stretching cosmos. Even as space grows darker, as galaxies fade into the expanding silence, there is comfort in knowing that this quiet, unchanging void has been present for billions of years, shaping the universe while remaining hidden from direct perception. The darkness is not empty. It is filled with unseen forces, silent motion, and the slow, inexorable rhythm of cosmic time. Even as the universe expands and dark energy stretches the cosmic void, islands of light remain, remnants of stars that once burned brightly. These stellar remnants, white dwarfs, neutron stars, and black holes, serve as the last sources of illumination in an otherwise darkening cosmos. They are beacons in the void, brief islands of energy amidst vast emptiness. White dwarfs, for example, are the cooled cores of medium-sized stars, like our Sun. After exhausting their nuclear fuel, these stars collapse into dense, hot remnants, roughly the size of Earth, radiating faint light for billions of years. In interstellar space, this light is minimal, yet detectable by instruments. For an observer floating alone in the void, such stars would appear as tiny dim points, barely illuminating their surroundings. Neutron stars, formed from the supernova explosions of massive stars, are even stranger. These collapsed cores pack the mass of the Sun into a sphere only 20 kilometers across. Some spin rapidly, emitting beams of radiation detectable as pulses. To human eyes, the pulses would be imperceptible unless captured with precise instruments, but they represent a flicker of activity in the cosmic darkness, a heartbeat within the silent void. Black holes, in contrast, absorb all light that crosses their event horizon, creating the ultimate darkness. Even the surrounding accretion disks, glowing hot from matter spiraling inward, only highlight the contrast against their absolute black centers. Observing a black hole from space is witnessing darkness itself, light bent, absorbed, and ultimately erased. For astronauts or hypothetical travelers, it is a profound encounter with nothingness made physical, a place where light ceases to exist in the conventional sense. These remnants illustrate a critical truth. The universe's darkness is not uniform, light exists, but it is sparse, fleeting, and often confined to small, isolated regions. For anyone contemplating space, it is both humbling and mesmerizing. The stars we see today are survivors, the last expressions of processes that will eventually cease, leaving the cosmos darker and emptier still. From a psychological perspective, the sparse illumination of stellar remnants contributes to a unique cognitive state. The mind, trained to navigate environments rich in cues, receives only fragments of input. Shadows are complete, distances incomprehensible, and orientation minimal. Yet these faint glimmers of light provide reference, anchoring the observer in a reality that is otherwise overwhelming in scale and emptiness. In this way, the dying light of stars becomes both practical and poetic. It is a reminder of impermanence, of the fleeting nature of energy in an expanding universe, and of the fragile but persistent presence of order in a cosmos dominated by darkness. Even in the most extreme voids, the universe offers brief, delicate hints of illumination, inviting the mind to perceive, reflect, and drift quietly in the silent grandeur of space. As the universe ages, the era of abundant starlight gradually wanes. Star formation, which peaked around 10 billion years ago, has slowed significantly. Vast regions of galaxies are now consumed of the gas needed to birth new stars. The cosmos is entering a prolonged period of dimming, where the brilliant light of youthful galaxies will give way to fading embers scattered sparsely across expanding darkness. Imagine drifting among these dimming galaxies. Even the once bright spiral arms of the Milky Way and Andromeda are less luminous from the perspective of deep space. Stars that shine today will exhaust their fuel over billions or trillions of years. Medium-sized stars like our Sun will become white dwarfs, gradually cooling into black dwarfs, ceasing to emit light entirely. The universe is moving toward an epoch where visible illumination will become extraordinarily rare. This slow fading has profound implications for perception. For anyone observing the universe from interstellar or intergalactic distances, the night sky will no longer glimmer with countless stars. The voids will dominate even more, punctuated only by sparse remnants of past stellar activity. The emptiness between galaxies, already profound, will become the defining feature of the cosmos. Darkness will reign not because light is absent, but because the universe itself is running out of new sources of illumination. Psychologically, this transition underscores the ephemeral nature of cosmic light. The few surviving stars and remnants become anchors in the mind's perception of scale and distance. Their presence, tiny and isolated, highlights the immensity of the void around them. Astronauts or hypothetical observers far from any bright object would experience a profound sense of solitude, an existential quiet, where even light itself seems temporary. Instruments such as the James Webb Space Telescope provide a glimpse into these future conditions by detecting faint, distant galaxies whose light is redshifted into infrared. These observations remind us that even in the era of fading starlight, the universe is still active, still evolving, but in ways that are imperceptible to the human eye. The darkness that dominates our perception is a combination of vast distance, photon dilution, and the universe's gradual dimming. Ultimately, the twilight of the universe teaches us to appreciate the rare light that exists. Even amidst the expansive darkness, these glimmers allow orientation, reflection, and contemplation. They highlight the impermanence of all things, including energy and matter, and evoke a quiet, meditative awe, an invitation to drift in thought as the universe itself drifts toward its darker, quieter future. In the distant future, trillions of years from now, the universe will enter what scientists call the heat death, a state of maximum entropy where all usable energy has been expended and the cosmos is plunged into absolute darkness and near zero temperature. No new stars will form. Existing stars will have exhausted their fuel, with massive stars already collapsed into black holes and medium-sized stars cooled into black dwarfs. Small red dwarfs, the last long-lived stars, will eventually burn out as well, leaving the universe in an unbroken shadow. Imagine drifting in this extreme void. No stars, no galaxies visible, only the faint remnants of radiation from long extinct sources. Black holes, once centers of immense energy, will slowly evaporate via Hawking radiation, a process taking unimaginably long timescales. Over 10 to the power of 100 years, even supermassive black holes will vanish, leaving a universe devoid of significant structures, light, or motion. The cosmos will become a silent, featureless expanse stretching indefinitely. For a human observer, hypothetically able to survive in such a distant epoch, the psychological impact would be profound. The mind, evolved in a world filled with light and constant sensory input, would face absolute sensory deprivation. With no visual cues, no photons reaching the retina, and no environmental sounds, the brain would be forced into a state of complete introspection. Sensory input would be non-existent, and cognition would rely entirely on internal signals. Yet there is a peculiar serenity in imagining this heat-death universe. The absence of change, the infinite calm, and the uniformity of the void evoke a quiet, meditative perspective. Unlike earlier cosmic epochs filled with energetic processes and brilliant light, this era offers a contemplative stillness, a backdrop against which reflection on existence itself becomes almost inevitable. Instruments would still detect traces of particles and radiation, cosmic neutrinos, the faint glow of Hawking radiation, but to the naked eye, the universe would be profoundly dark. The knowledge that all structure, all matter, and all energy has reached its endpoint gives context to our current epoch. We exist in a rare, bright era where stars shine, galaxies cluster, and life can perceive light and complexity. From a philosophical standpoint, the heat death represents the ultimate impermanence. It reinforces the notion that light, structure, and energy are temporary features of a universe governed by physical laws. The darkness we see today between stars and galaxies is a foretaste of what awaits on cosmic timescales, an eternal, silent, and absolute void, yet a void that can inspire reflection, acceptance, and a tranquil sense of the sublime. Even in imagining such extreme darkness, there is comfort. The universe's journey from the bright glow of early stars to this ultimate heat death is a story of transformation, scale, and inevitability. For humans contemplating it, the vast silence offers a space for thought, meditation, and a sleepy appreciation of the ephemeral brilliance that once existed, and, for now, still exists, in our cosmic neighborhood. As humanity ventures further into space, one of our most essential tools against the overwhelming darkness is artificial light. Unlike the natural stars and galaxies that dot the universe, our spacecraft and habitats carry illumination with them, creating small islands of visibility in an otherwise absolute void. LEDs, the modern standard, provide efficient, long-lasting light while generating minimal heat, critical in the vacuum of space, where temperature regulation is essential. On the International Space Station, hundreds of LEDs are carefully distributed throughout the modules. Their intensity and color are adjusted to mimic Earth's natural day-night cycles, helping astronauts maintain circadian rhythms disrupted by the rapid orbit of the station. 16 sunrises and sunsets per 24 hours. Without these artificial cues, sleep, alertness, and cognitive performance would deteriorate rapidly. Light becomes not just illumination, but a cornerstone of survival. During extravehicular activities, astronauts rely on helmet-mounted lights to create localized visibility. Tools, instruments, and parts of the spacecraft emerge from the shadows only when illuminated. A small misalignment or dropped object can vanish instantly into the surrounding void. Artificial light, in this context, is both practical and psychologically essential. It offers orientation, structure, and a sense of control amidst overwhelming darkness. For those imagining themselves on long-duration missions to the Moon, Mars, or beyond, artificial light also serves an emotional function. Looking out a spacecraft window, an astronaut might see only blackness stretching for millions of miles. Yet inside, warm human-designed lighting provides comfort, focus, and a connection to familiar diurnal rhythms. These bubbles of light transform the void from a disorienting, potentially stressful environment into a habitable, reassuring space. Advanced habitat designs for future interstellar missions take this even further. Some propose large interior spaces with artificial skies, simulating blue skies, clouds, or even sunsets. Others suggest subtle light variations to indicate the passage of time, ensuring crew members maintain mental health and circadian alignment. The darkness outside remains absolute, but inside, human ingenuity creates a private universe of illumination. This interplay between human-made light and natural cosmic darkness highlights a central theme. Space is not inherently hostile, but it is indifferent. The universe provides no guidance, no ambient illumination, no cues for survival. Humanity brings light into the void, both literally through LEDs and lamps, and metaphorically through understanding, planning, and culture. In the cosmic silence, these small points of light remind us of our presence, our ability to adapt, and our capacity to create warmth and order in an environment defined by emptiness. While the void between stars remains overwhelmingly dark, human light ensures that exploration, perception, and comfort are possible even in the deepest reaches of space. In the vacuum of space, light and darkness exist in stark opposition. Unlike on Earth, where our atmosphere scatters sunlight and softens shadows, space presents a universe of extreme contrast. One side of a spacecraft may be blindingly illuminated by direct sunlight, reaching temperatures of over 120 degrees Celsius, 250 degrees Fahrenheit, while the shadowed side plummets to below -157 degrees Celsius, -250 degrees Fahrenheit. There is no air to distribute heat, no dust or particles to diffuse light, just sharp absolute differences between illuminated and dark regions. For astronauts performing spacewalks, this contrast is more than theoretical. Tools and parts can disappear instantly into shadows. A glove extended beyond the sunlight may vanish entirely from view. The brain, conditioned to detect even subtle variations in tone and shade on Earth, is confronted with a void where subtlety does not exist. Darkness is not dim, it is absolute. Light is not diffuse, it is harsh, almost violent in its brilliance. Even celestial objects display this relentless duality. On asteroids, moons, and planets with no atmosphere, sunlight casts sharp, unforgiving shadows. Craters and ridges may be invisible in darkness, while illuminated terrain appears stark and monochromatic. On a sunlit surface, colors are muted, textures exaggerated, and shadows are so deep that the mind struggles to interpret scale or depth. The interplay of extreme brightness and total darkness creates a visual landscape that is both beautiful and alien. This contrast also affects the psychological experience of space. Humans rely on gradual transitions of light, for orientation and emotional cues. On Earth, dawn and dusk signal activity, rest, or change. In space, the absence of such transitions amplifies the feeling of isolation. Astronauts must rely on instruments, artificial lighting, and meticulous attention to orientation. The void outside is indifferent. It offers no cues or comfort. Yet within this stark contrast lies a form of meditative clarity. The brain, stripped of subtle gradations, focuses on essentials. Shadows delineate structure, sunlight reveals surfaces, and the absence of scattered light simplifies perception in a paradoxical way. Observers can learn to navigate this extreme environment, finding calm in the predictability of absolute darkness juxtaposed against sharply defined illumination. For anyone contemplating human exploration, the lesson is clear. Surviving and thriving in space requires understanding this contrast. The interplay of light and darkness defines physical conditions, visual perception, and psychological well-being. While the universe outside remains overwhelmingly dark, human ingenuity transforms it into a navigable, manageable, and even awe-inspiring environment. The cosmic void is extreme, but in contrast, human light creates order, meaning, and a quiet, sleepy reassurance amidst the vast darkness. One of the most perplexing truths about the cosmos is the night sky paradox, also known as Olber's paradox. If the universe were infinite, unchanging, and filled with stars like our sun, then every line of sight should eventually hit a star. The sky, even at night, would be blazing with light. Yet when we look up from Earth, darkness dominates. Stars twinkle sparsely across a black canvas, and the Milky Way appears as a faint band, not a continuous wall of light. For anyone gazing at the stars, this paradox may seem like a curiosity, but it has profound implications for understanding the universe's structure and history. The darkness we see confirms that the universe is finite in age and expanding. Light takes time to travel. The observable universe is limited to objects whose light has had time to reach us since the Big Bang, approximately 13.8 billion years ago. Beyond that horizon, light simply has not arrived, leaving us in darkness. Moreover, the expansion of space stretches the wavelengths of light from distant galaxies. This cosmological redshift shifts visible light into infrared or microwave frequencies, effectively rendering it invisible to the naked eye. Even though countless galaxies exist and emit enormous amounts of light, much of it is beyond our perception. What we see as darkness is the product of distance, expansion, and the finite speed of light. Astronomers detect these phenomena indirectly. The cosmic microwave background radiation, a faint afterglow of the Big Bang, fills the sky uniformly, yet it is invisible without instruments sensitive to microwave wavelengths. The universe is far from empty, but its light is largely inaccessible to human vision. What our eyes perceive as night is a fraction of the electromagnetic symphony surrounding us. Psychologically, the paradox deepens the cosmic perspective. The universe is full, yet our perception captures only a tiny sliver. Darkness dominates not because light is absent, but because our senses are limited. For humans contemplating this, the experience evokes both humility and a meditative calm. The vast, unlit expanse reminds us of our smallness, yet also of our ability to perceive, measure, and understand phenomena far beyond direct experience. The night sky paradox is also a subtle comfort. It demonstrates that darkness is a natural feature of the universe's structure, not a failure of perception. The cosmos is vast and expanding, with light as a rare, precious exception. As we explore and understand, we find that darkness is not empty. It is a canvas for curiosity, reflection, and a sleepy awe that stretches across time and space. Even as we understand the physics of light and darkness, our perception of the universe remains strikingly limited. Human eyes evolved to detect the wavelengths most abundant from our Sun and filtered by Earth's atmosphere, roughly 400 to 700 nanometers, the visible spectrum. This is less than 2% of the electromagnetic spectrum, leaving vast realms of light, infrared, ultraviolet, X-rays, gamma rays, beyond our natural senses. Floating in space, even near a bright star, your eyes capture only a fraction of reality. Billions of photons pass unobserved, streaming past atoms, empty space, and your retinas. Cosmic structures glow brightly in wavelengths invisible to us, revealing the complexity of galaxies, nebulae, and interstellar dust that our eyes would never detect unaided. Instruments like the James Webb Space Telescope extend perception into the infrared, uncovering galaxies formed just hundreds of millions of years after the Big Bang, long before our visible light telescopes could detect them. This distinction between visible and invisible light is central to understanding cosmic darkness. What appears utterly black may, in fact, be filled with radiant activity undetectable to the unaided eye. The universe's emptiness is partly a limitation of human biology, a boundary of perception rather than an absence of phenomena. Even the so-called darkest regions teem with photons, cosmic rays, and subtle electromagnetic signals streaming silently through the void. Psychologically, this reinforces a profound lesson. Darkness is relative. To our eyes, interstellar and intergalactic space is overwhelmingly black. To instruments, it is vibrant, structured, and informative. Humans floating in this environment encounter emptiness, yet the universe itself remains active. The mind must reconcile perceived nothingness with objective abundance, a tension that evokes humility, curiosity, and paradoxically, a quiet contemplative calm. For anyone imagining themselves adrift in the cosmic void, the realization is profound. Our senses experience only a narrow fraction of reality, yet with technology, training, and contemplation, we glimpse the broader truth. The darkness is not absolute. It is filtered, constrained, and shaped by perception. This subtle understanding transforms cosmic emptiness from something terrifying into an invitation to explore, to measure, and to reflect, finding serenity amidst vast, unseen complexity. On Earth, the night sky is rarely experienced in its natural state. Artificial lighting from cities, streets, and homes creates a pervasive glow that obscures stars, planets, and the Milky Way. Around 80% of the world's population now lives under light-polluted skies, and in regions like the United States and Europe, this figure exceeds 99%. Most people have never seen thousands of stars filling the heavens, nor the faint glow of distant galaxies that punctuate the natural darkness. This artificial brightness transforms perception. What we consider night is only partially dark. Streetlights, illuminated buildings, and vehicle headlights scatter photons into the atmosphere, creating a diffuse ambient glow that prevents human eyes from adjusting to true darkness. Even in rural areas, subtle reflections from nearby towns or moonlight prevent the full experience of the natural night sky. The universe, in its deepest sense, remains hidden behind layers of human-made illumination. For spacebound humans, this contrast is echoed on a larger scale. In spacecraft or lunar habitats, artificial lighting provides orientation, circadian regulation, and psychological comfort. Without it, extended exposure to cosmic darkness could cause disorientation, sleep disruption, and cognitive stress. Yet, while technology shields us from overwhelming emptiness, it also distances us from the experience of pure, unfiltered darkness that defines interstellar space. Dark sky preserves on Earth offer a glimpse of what space truly looks like. Far from cities, in carefully protected areas, thousands of stars become visible. The Milky Way stretches across the sky, and distant planets shine brightly. Experiencing these conditions evokes awe, quiet reflection, and a subtle, sleepy relaxation as the mind absorbs the immensity and silence of the cosmos. The interplay between artificial light and natural darkness teaches humans the value of both visibility and void. Psychologically, this reveals a deep connection. Humans evolved under cycles of light and dark, with darkness essential for sleep, mental health, and circadian rhythms. Our fascination with the stars, our drive to explore, and our response to cosmic vastness are all shaped by this balance. While artificial light allows extended activity and technological advancement, it also masks the profound, quiet, and meditative truth of the universe. A darkness that is both absolute and illuminating in its absence. The lesson is subtle, yet profound. Darkness is not merely the absence of light. It is a canvas for reflection, exploration, and understanding. Whether on Earth or in space, experiencing true darkness connects humans to the scale, structure, and history of the cosmos, evoking awe, serenity, and a sleepy contemplation of the universe's infinite expanse. On the Moon, darkness is immediate, absolute, and unfiltered. Unlike Earth, the Moon has no atmosphere to scatter sunlight, no clouds to diffuse it, and no air molecules to create twilight. When the sun sets, the lunar surface plunges into night with an abruptness that is disorienting to the unprepared observer. This darkness lasts approximately 14 Earth days, stretching across vast plains, craters, and mountains, with no ambient light beyond the faint glow of Earth or distant stars. For astronauts and future settlers, this presents both practical and psychological challenges. During lunar night, even the largest Earth-reflecting light is insufficient for detailed observation. Shadows become inky voids where no texture or depth is discernible. Astronauts must rely entirely on artificial lighting for navigation, construction, or scientific work. A drop tool or misplaced equipment can vanish instantly into the shadows, irretrievable unless illuminated. This creates a unique environment where every light source becomes precious, and the absence of light is immediate and absolute. The psychological impact of lunar darkness is profound. Humans evolved under gradual transitions of light, dawn, dusk, moonlight, and atmospheric scattering. The sudden onset of 2-week-long night on the Moon strips away these familiar cues. Astronauts must adapt to the absence of visual markers, orientation cues, and reference points. Studies suggest that prolonged exposure to such conditions can induce mild sensory deprivation, altered time perception, and heightened emotional sensitivity. The mind, accustomed to interpreting subtle visual information, is forced into introspection and quiet reflection. Interestingly, the Moon provides a rare counterpoint to the cosmic void. Earth, suspended in the lunar sky, becomes a glowing beacon, a familiar reference point that offers orientation and emotional comfort. Its reflected light is far brighter than typical moonlight on Earth, due to the relative size and reflectivity of the planet. Yet it is still insufficient to illuminate terrain in detail. For humans on the lunar surface, this creates a constant interplay between profound darkness and isolated points of illumination, a visual and psychological rhythm that must be navigated carefully. Artificial lighting becomes not only a tool, but a lifeline. Lunar habitats, rovers, and external equipment rely on LEDs and other lighting technologies optimized for energy efficiency and spectrum control. Light must be carefully managed to maintain circadian cycles, prevent fatigue, and provide a sense of normalcy amidst an alien environment. The contrast between illuminated zones and the encompassing blackness of lunar night mirrors, on a smaller scale, the experience of interstellar darkness. It teaches humans to navigate, survive, and even find a meditative calm in environments that are extreme, disorienting, and fundamentally unlike the Earth they evolved on. Beyond practical considerations, the lunar night offers a unique opportunity for introspection. The sky above, black and unbroken by atmospheric scattering, reveals countless stars, distant galaxies, and the faint glow of the Milky Way. This exposure to near-perfect darkness, combined with the sharp clarity of celestial light, provides a perspective on scale, time, and human significance. Astronauts report feelings of awe, humility, and meditative relaxation, emotions that are amplified by the absence of intermediary illumination. The lunar night, then, is a bridge between earthbound experiences and the cosmic void. It demonstrates the challenges and beauty of absolute darkness, illustrating the interplay of human perception, artificial illumination, and the natural environment. For anyone contemplating life beyond Earth, understanding the lunar night is essential. It is both a laboratory and a warning, a place where darkness is profound, yet human ingenuity and psychological adaptation allow survival, exploration, and even quiet contemplation of the universe's vast, silent, and awe-inspiring expanse. Mars presents a unique relationship with darkness, subtly different from both Earth and the Moon. Its thin atmosphere scatters sunlight, creating soft twilight, rather than the abrupt nightfall seen on the Moon. Sunlight on the Martian surface is roughly 43%, as intense as on Earth, and as the sun dips below the horizon, the sky transitions gradually from pale orange to deep crimson, eventually fading into an almost absolute black. This creates a distinct mood. The darkness on Mars is both isolating and contemplative, a liminal state between day and night that stretches the perception of time and space. Astronauts and explorers on the Martian surface would confront challenges that combine lunar extremes with new variables. During the day, shadows are defined but less dark than on the Moon, due to the scattered light. At night, the weak sunlight of the two Martian moons, Phobos and Deimos, adds tiny points of reflection, yet the vast majority of the landscape remains unlit. Deep craters, shadowed rock formations, and distant dunes vanish into the darkness, creating disorienting visual conditions. Humans must rely heavily on artificial illumination for navigation, scientific measurements, and survival. The psychological effects of Martian night are profound, but subtly different from lunar darkness. The faint twilight creates a perception of transition and softening, reducing some of the immediate shock experienced on the Moon. Yet the vast, empty landscape, punctuated by distant dim stars and the tiny glowing moons, fosters introspection and a heightened sense of isolation. Humans evolved under Earth's atmospheric light diffusion and circadian rhythms must adapt to these new conditions. Without artificial lighting and structured schedules, sleep disruption, fatigue, and mild cognitive strain could occur over extended periods. Artificial light on Mars is both practical and psychological. Habitats, rovers, and workstations employ LED systems optimized to replicate Earth-like day-night cycles. Bright illumination for tasks, warmer ambient light for rest, and strategically placed lights for safety help maintain human orientation and mental health. Beyond mere survival, these light sources provide comfort against the overwhelming void beyond the immediate habitat, a reminder of human presence and structure amidst the planet's expansive shadows. The Martian night also offers profound observational opportunities. Without Earth's thick atmosphere, the sky is clearer than on Earth. Stars and galaxies appear sharper, and constellations are unmixed by scattered light. The Milky Way stretches across the sky with crisp clarity, and even subtle celestial phenomena, like meteor streams or the faint glow of distant galaxies, become visible. This juxtaposition of near-total darkness and isolated points of light creates a unique meditative experience for the mind. Awe and serenity in equal measure, a quiet acknowledgement of scale, time, and cosmic perspective. For anyone contemplating the human experience of space, Martian darkness exemplifies the interplay of environmental extremes, perception, and adaptation. It is neither as abrupt as the lunar night nor as unbroken as interstellar voids, but it is profoundly alien. Survival, navigation, and psychological resilience require preparation, ingenuity, and careful management of artificial light. And yet, within this subtle darkness, humans can find stillness, reflection, and a sleepy sense of wonder, connecting our minds to the vast, quiet, and beautiful cosmos that surrounds us. As we journey beyond Mars into the outer reaches of the solar system, the sun becomes a faint, distant star. On Jupiter, sunlight is only about 4% of Earth's intensity. On Saturn, roughly 1%. And by the time we reach Uranus and Neptune, sunlight has diminished to mere fractions of its terrestrial brightness, 0.27% and 0.11%, respectively. The planet's moons experience a world of deep twilight, where shadows are profound, and the difference between illuminated surfaces and black void is striking. Astronauts or robotic explorers venturing here confront extremes. On Jupiter's moons, the sun might appear as a bright star, sufficient to cast faint shadows. Yet the surrounding void is overwhelmingly dark. When sunlight is absent, surface features vanish into blackness. Instruments can detect topography and movement, but human eyes alone would see only deep, featureless shadows. Without artificial lighting, basic tasks, navigation, equipment handling, or scientific observation become impossible. The cosmos outside the immediate lighted area is absolute darkness. The psychological experience of the outer solar system is unique. Humans evolved under conditions of a bright sun, gradual twilight, and atmospheric scattering of light. In this distant domain, light is sparse, shadows are profound, and reference points are minimal. The mind must rely heavily on internal cues, instruments, and artificial illumination to maintain orientation and sanity. Prolonged exposure to such darkness could heighten feelings of isolation, alter perception of time, and amplify the sense of cosmic insignificance. Artificial light is therefore not optional, it is essential. Habitats on moons such as Titan or Ganymede would require comprehensive lighting systems. LED arrays, adjustable brightness, and color temperature control help maintain circadian rhythms, prevent disorientation, and support mental health. Shadowed regions around work areas must be illuminated carefully to prevent accidents and maintain a clear sense of space. Even brief tasks conducted outside the habitat would demand helmet-mounted lights or portable illumination, creating small islands of visibility within a vast, unlit environment. Titan presents a special case. Its thick, hazy atmosphere scatters sunlight, producing a permanent twilight. Even at noon, illumination is dim, about 1% of Earth's sunlight, and shadows remain muted. While this reduces the abruptness of transitions between day and night, it still challenges visual perception. Details are hard to discern, colors are subdued, and distant features fade into the hazy darkness. Artificial light remains crucial for survival and exploration, both practical and psychological. Yet amidst these extreme conditions, the outer solar system offers profound visual experiences. The darkness beyond illuminated surfaces is pristine, unpolluted, and deep. Stars shine sharply without atmospheric interference. Galaxies, nebulae, and cosmic phenomena appear crisp, providing a direct connection to the universe's scale and history. For the human mind, this combination of isolation, extreme darkness, and distant light can be meditative, a sleepy awareness of the cosmos that is simultaneously humbling and calming. The outer planets teach a crucial lesson. As humans venture further from the sun, darkness dominates. Survival, perception, and psychological well-being depend on understanding, harnessing, and creating light. In these distant worlds, light is rare, shadows are absolute, and the void stretches in every direction. But within careful illumination, humans can navigate, explore, and even find serenity amidst the vast, quiet expanses of space. Beyond Neptune lies the Kuiper Belt, a vast ring of icy bodies, dwarf planets, and remnants from the solar system's formation. Here, sunlight is reduced to a faint glimmer, mere 0.1% of Earth's intensity, casting long, inky shadows across distant frozen surfaces. Objects like Pluto, Arakoth, and countless smaller bodies exist in near total darkness, illuminated only by the sun's weakened rays and occasional reflections from neighboring objects. For explorers venturing into this realm, darkness dominates every aspect of experience. Surfaces are uneven, craters and ridges are hidden in shadows, and the vast distances between objects make navigation challenging. Even advanced telescopes and sensors must compensate for the dim illumination, relying on precise optics and artificial lighting to resolve terrain and measure composition. The naked eye alone would perceive almost nothing beyond the spacecraft or habitat's immediate vicinity. This environment pushes the limits of human perception. Without the familiar cues of sunlight, atmosphere, or nearby landmarks, spatial orientation becomes difficult. Prolonged exposure can disrupt circadian rhythms and heighten psychological stress. Observers must rely on instruments, LED illumination, and carefully planned light management to maintain both practical function and mental equilibrium. The void surrounding these distant worlds is absolute, indifferent, and continuous, emphasizing the vast emptiness at the edges of the solar system. Yet, amidst this profound darkness, there is beauty. The Kuiper Belt presents a quiet cosmic stage where the faint glow of distant stars punctuates the black sky. Solar reflections on icy surfaces create subtle, ghostly highlights. Observers experience a sense of scale, unlike anywhere else in the solar system. The distances between objects are immense, the light minimal, and the shadows absolute. It is a space that invites reflection, a meditative environment where the mind can wander, contemplate, and slowly absorb the enormity of the universe. The psychological contrast between faint light and vast darkness becomes particularly striking on bodies like Pluto or Arakoth. Artificial light illuminates the immediate surroundings, revealing subtle details of terrain, ice formations, and surface textures, while everything beyond remains unlit and undefined. This interplay reinforces a core principle of space exploration. Light is not merely illumination, it is orientation, safety, and a bridge between human cognition and the alien environment. For missions venturing into the Kuiper Belt, planning for light management is critical. Habitats, rovers, and workstations must provide reliable illumination, both for practical tasks and psychological well-being. Even small, localized light sources can create a sense of security and structure within a cosmic environment that is overwhelmingly dark. This region teaches humans to navigate darkness on a scale far beyond Earth or inner solar system experience, blending technology, psychology, and sensory adaptation to thrive amidst the silent, frozen twilight of the solar system's outer reaches. In the Kuiper Belt, darkness is profound, immutable, and absolute. But within controlled light, humans can find clarity, orientation, and a meditative connection to the vast, cold, and quiet cosmos surrounding them. Beyond the outer planets, humanity has sent robotic explorers into the vast expanse of interstellar space. Voyager 1 and Voyager 2, launched in 1977, have traveled farther than any human-made object, now more than 15 billion miles from Earth. At this distance, the Sun is no longer a blazing disk, but a faint point of light, outshone by distant stars only subtly. The darkness surrounding these spacecraft is complete, a profound illustration of space's true void. For the Voyagers, darkness is not theoretical. It is the operational reality. Instruments must detect objects and measure conditions without reliance on visible illumination. Solar radiation is weak, ambient light is negligible, and the surrounding interstellar medium is nearly a perfect vacuum, with roughly 1 atom per cubic centimeter. Photons travel freely, but unless intercepted by the spacecraft's sensors, they pass unnoticed. The universe at this distance is an ocean of darkness, punctuated only by distant, faint stars. Psychologically, imagining being on Voyager evokes an acute awareness of isolation. Earth is invisible, reduced to a point of light smaller than any perceptible feature. The nearest stars, though theoretically closer than millions of others, are still trillions of miles away. There is no horizon, no reference, and no ambient cues. The mind, trained on Earth's abundant light and proximity of surfaces, encounters a total sensory vacuum, a cosmic silence beyond comprehension. Despite this, Voyager carries light in another form: information. The golden record affixed to each spacecraft contains sounds, images, and music representing humanity. In the deep darkness of interstellar space, this record is a human-made beacon, a message in a cosmic bottle. While physical illumination is absent, these artifacts symbolize light in the form of knowledge, culture, and intention, a counterpoint to the surrounding void. The environment around Voyager illustrates a central truth of cosmic darkness. Light exists only where it interacts with matter or instruments. In the interstellar void, photons pass unnoticed until captured. Humans, adapted to an environment rich in scattered light, would perceive nothing. The darkness is absolute, unchanging, and indifferent. Yet through technology, meaning and observation can be projected into this void, allowing navigation, discovery, and reflection. Voyager's journey is a meditation on scale, distance, and perception. The spacecraft drifts silently through interstellar space, an artifact of human curiosity in an ocean of darkness. The faint points of light in the distance offer no orientation, only a reminder of vast distances and human smallness. Yet within this darkness, humanity's presence, through instruments, signals, and the golden record, creates islands of understanding, a quiet interplay of light and information against the unbroken void. For anyone imagining themselves alongside Voyager, the lesson is profound. Darkness is not inherently threatening. It is indifferent. Survival, exploration, and comprehension depend on creating light, both literal and metaphorical. In the interstellar void, humans and their machines demonstrate that even amidst absolute blackness, knowledge, reflection, and quiet observation bring purpose, orientation, and a contemplative serenity to the cosmos' immense emptiness. Launched in 2006, New Horizons ventured farther than any previous spacecraft to explore the outer reaches of our solar system. Its encounter with Pluto in July 2015 revealed a world both distant and dim, bathed in sunlight, equivalent to only about 0.06% of Earth's illumination. Even at noon on Pluto, the sun casts faint, elongated shadows across icy plains, while the surrounding sky remains black and filled with distant stars, providing no ambient light. For a human observer on Pluto, visual perception would be extremely limited. Shadows are profound, craters and surface features invisible unless directly illuminated. Without artificial light, navigation and exploration would be nearly impossible. New Horizons itself relied on carefully calibrated instruments, including high-sensitivity cameras and spectrometers, to capture details invisible to human vision. The icy mountains, nitrogen glaciers, and potential cryovolcanoes revealed the complexity of a world living almost entirely in darkness. Beyond practical considerations, Pluto illustrates the psychological experience of extreme isolation. The sun, distant and faint, offers minimal orientation. Shadows stretch and deepen without the moderating effect of an atmosphere, creating a stark alien landscape. The mind, accustomed to Earth's dynamic lighting, must adapt to near total darkness, interspersed with faint, unchanging illumination from distant stars. Time perception, spatial awareness, and visual cognition all face challenges in such an environment. The Kuiper Belt object Arrokoth, explored by New Horizons in January 2019, further exemplifies this reality. A pristine, distant body over 4 billion miles from the Sun, it exists in perpetual twilight. Its contact binary shape is only discernible due to careful observation with spacecraft instruments. The naked eye would see nothing but featureless darkness. These distant objects highlight how light diminishes with distance and how cosmic darkness dominates even within our solar system's periphery. Artificial light remains essential for exploration and potential human presence in these regions. Habitat design, vehicle navigation, and scientific operations rely on LEDs and instrument-assisted visibility. Even brief illumination provides a psychological anchor, preventing disorientation and enhancing perception in an environment otherwise defined by shadows and unrelenting blackness. The New Horizons mission demonstrates a crucial principle. Even in the solar system's dimmest, most distant realms, human technology transforms darkness into an observable, navigable, and meaningful environment. The edge of our system is a laboratory for understanding cosmic darkness on both practical and contemplative levels. It offers a quiet reflection on scale, light, and perception, a sleepy awe at the distant, faintly illuminated frontier of human exploration. Beyond the Kuiper Belt, spacecraft and potential human explorers face a profound reality: absolute isolation. In interstellar space, distances are measured in light years, and every celestial object is separated by vast, empty voids. The nearest star beyond the Sun is Proxima Centauri, over 4.24 light-years away, or roughly 25 trillion miles. Between these stars lies darkness so complete that human senses perceive nothing: no light, no sound, no visual cues. Psychologically, this environment is disorienting. Humans evolved on Earth, surrounded by sensory feedback: light, shadow, sound, texture, and air. In interstellar space, these inputs vanish. The mind, deprived of external signals, begins to create its own. Research on sensory deprivation shows that extended periods without stimulation can trigger hallucinations, distortions of time, and vivid mental imagery. In deep space, the absence of photons reaching the eyes produces similar effects. Astronauts or hypothetical voyagers could experience geometric patterns, imagined landscapes, or phantom lights as the brain attempts to interpret nothingness. Isolation in deep space compounds these effects. Unlike orbital missions or lunar expeditions, there is no nearby Earth, no familiar planet, no immediate rescue. Radio communications, even at light speed, are delayed by years at interstellar distances, eliminating the psychological comfort of connection. Human perception of scale is challenged, distances are incomprehensible, and the concept of proximity loses meaning. The void is not hostile, it is indifferent, but its sheer emptiness can evoke profound existential reflection. Artificial lighting and structured environments become essential for survival. Habitats must simulate Earth-like day-night cycles to maintain circadian rhythms, provide safe illumination for tasks, and support psychological well-being. Even small visual cues, LED lighting, instrument displays, and illuminated markers anchor perception within the infinite dark. The brain relies on these cues to maintain orientation, regulate sleep, and preserve mental resilience. Yet there is a paradoxical benefit to this isolation. The extreme darkness, the absence of sensory clutter, and the slow movement of celestial objects can produce a meditative state. Observers may experience a quiet introspection, a deep awareness of the universe's scale, and a reflective calm. The void becomes both a challenge and a space for contemplation, a canvas for the mind to process cosmic perspective, human significance, and the passage of time on an incomprehensible scale. In this way, deep space illustrates the dual nature of cosmic darkness. It is both threatening and profoundly peaceful. The absence of light and familiar stimuli challenges human cognition, yet it also provides an unparalleled environment for reflection, meditation, and a sleepy awareness of the universe's immensity. Understanding and adapting to this environment is as much psychological as it is technological, and it is essential for any future journey into the far reaches of the cosmos. In the vast expanse of deep space, light is rare and shadows are absolute. Unlike Earth, where atmospheric scattering illuminates the sky even at night, interstellar space presents stark contrasts. Distant stars are mere pinpoints, sunlight is faint beyond the solar system, and the darkness between objects is profound. Navigation here is not guided by visible light, but by precise instrumentation, sensors, and careful calculation. For spacecraft traveling beyond the Kuiper belt, instruments detect photons across the electromagnetic spectrum, radio waves, infrared, X-rays, compensating for what human eyes cannot perceive. Light only becomes meaningful when it interacts with matter or detectors. Otherwise, it passes unnoticed through the void. The darkness is complete to the observer, yet data-rich to the instruments designed to translate imperceptible signals into actionable information. Psychologically, this environment challenges human perception. Astronauts or explorers must rely entirely on artificial lighting for immediate tasks, while situational awareness depends on computers and sensors to interpret the invisible universe. Shadows on spacecraft surfaces become absolute. Objects outside illuminated zones vanish into the void. The brain, adapted to subtle gradients on Earth, must adjust to stark, black and white conditions, processing limited visual information to maintain orientation and prevent cognitive overload. Artificial light in deep space serves multiple functions. Helmet-mounted lamps illuminate tools and work areas. LED arrays inside habitats regulate circadian rhythms, and external spotlights provide critical orientation during extravehicular activities. Even minimal illumination can create a sense of order within a universe dominated by indifference and emptiness. Light becomes not just a tool, but a psychological anchor, a bridge between human perception and the vast, silent cosmos beyond. The contrast between light and darkness also highlights cosmic scale. In the interstellar void, distances are so vast that even bright stars appear as faint points. Shadows are immense, stretching across surfaces and spaces with no atmospheric scattering to soften them. This environment trains the mind to operate in extreme conditions. Spatial reasoning, timing, and attention must adapt to a world where familiar visual cues are absent, replaced by stark illumination and profound blackness. Yet this darkness carries beauty. When artificial light illuminates nearby surfaces, it stands out sharply against the surrounding void. Distant stars punctuate the black canvas, creating a visual and cognitive rhythm that is simultaneously stark and calming. Observers experience a profound sense of scale, isolation, and serenity, a sleepy appreciation of the universe's structure, the rarity of light, and the quiet majesty of absolute darkness. In interstellar travel, mastering the interplay of light and shadow is essential. Human survival, cognition, and exploration depend on creating manageable pockets of illumination amidst the cosmic void. Darkness is overwhelming, but within the careful use of light, humans can navigate, work, and reflect, finding calm and focus in the extreme silence and vast blackness that defines the true universe. Among the darkest objects in the universe, black holes occupy a place of absolute darkness. Formed from the collapse of massive stars, their gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. To observe a black hole directly is to witness the literal absence of light, a circular void against the backdrop of stars, an invisible presence defined only by the effects it has on surrounding matter. For astronauts hypothetically near a black hole, the visual experience is surreal. The light from nearby stars bends due to extreme gravitational forces, forming a warped halo around the black void. But at the center, all illumination disappears. Ordinary perception fails entirely, eyes detect nothing, and even the brain's ability to interpret shadows is rendered meaningless. The darkness is not simply absence, it is final, absolute, and physical. Surrounding the black hole, an accretion disk of hot gas and dust glows intensely, providing the only visible reference. Material spiraling inward radiates X-rays and visible light, but this is the exception, highlighting the black hole's emptiness rather than filling it. The contrast is extreme. Bright dynamic light adjacent to a perfect void, creating one of the most visually and conceptually striking features of the cosmos. Psychologically, encountering such darkness would challenge human cognition. On Earth, darkness is contextual. The brain interprets shadows, contours, and ambient cues. Near a black hole, the absence of information is absolute. There is no horizon, no reference, no gradation, just a void. Extended exposure could induce disorientation, existential reflection, or a meditative calm as the mind grapples with the scale, power, and unyielding emptiness of the object. Observationally, black holes teach a critical lesson about cosmic darkness. Light is relative, perceptible only through interaction with matter or instruments. What is invisible to the eye is real and powerful, shaping nearby stars, bending space-time, and influencing entire galactic centers. The darkness we perceive is a measure of our senses, not of the absence of cosmic activity. Even conceptually, black holes are anchors in the meditation on the universe. They embody the extremes of mass, gravity, and light absorption. They remind us that in the cosmos, darkness is not merely empty. It can be active, structured, and absolute, existing alongside brilliant, energetic phenomena. For humans in space, understanding black holes is both a scientific necessity and a contemplative exercise, the ultimate illustration of cosmic darkness, where perception ends and the mind is invited to reflect on the profound limits of visibility, matter, and existence itself. Even in regions that appear utterly dark, the universe is never truly empty. At the quantum level, vacuum fluctuations create a restless, invisible activity that pervades all space. Particle-antiparticle pairs spontaneously emerge, exist for infinitesimal moments, and annihilate each other, releasing tiny bursts of energy. This phenomenon, called zero-point energy, occurs even in the vast voids between stars and galaxies, where visible light is absent. For humans imagining the interstellar void, this adds a paradoxical layer. Space appears completely black and inert, yet quantum physics reveals it is seething with imperceptible activity. The darkness we perceive is not absolute emptiness. It is the limit of human senses, filtered by the inability to detect phenomena at subatomic scales. Instruments sensitive to high-energy particles, cosmic rays, or fluctuations can detect these subtle events, bridging perception and reality. The philosophical implications are profound. If the void is active at quantum scales, then darkness is not simply absence, but a medium of unseen processes. What we perceive as stillness is a hidden theater of activity. Human cognition interprets darkness as emptiness, but physics suggests the universe is never inert, even in the most profound voids. The black sky, to the eye, masks a dynamic, energetic foundation underlying all of existence. Psychologically, this duality, perceived emptiness versus real activity, offers both humility and serenity. We are limited observers, capable of understanding only a fraction of reality, yet even our instruments can reveal hidden structure and motion, suggesting a universe far richer and more complex than direct observation allows. The void is quiet, yes, but it is also full of subtle, unseen life at a quantum scale, challenging the mind to expand its conception of space, energy, and existence. For spacefarers, this has practical implications. While the quantum vacuum does not threaten survival directly, it shapes the fundamental physics of space travel. Cosmic radiation, virtual particles, and zero-point energy influence spacecraft electronics, radiation shielding, and long-term mission planning. Even the emptiest regions of space are active arenas, invisible to the eye, but potent in effect. Ultimately, the quantum vacuum reframes darkness. It is not merely the absence of light, it is an underlying fabric of the cosmos, alive with transient phenomena beyond direct perception. For humans exploring the universe, understanding this hidden activity transforms the experience of darkness, from fear and emptiness to curiosity, reflection, and a quiet, sleepy awe at the unseen mechanisms that govern reality on scales both immense and infinitesimal. Beyond visible light and observable structures lies an even deeper level of darkness, the invisible majority of the cosmos. Approximately 27% of the universe's mass energy is dark matter, and about 68% is dark energy. Neither interacts with light in a way detectable by human eyes, yet their presence is undeniable, inferred from gravitational effects, cosmic expansion, and the motion of galaxies. Dark matter forms a vast, invisible scaffold for galaxies. It neither emits nor absorbs photons, making it literally invisible. Despite its stealth, it governs the structure of the universe. Without dark matter, stars and galaxies could not form, and cosmic architecture would collapse. For an observer traveling through interstellar space, this hidden matter remains unseen yet fundamental, shaping trajectories, gravitational fields, and large-scale patterns that define the cosmic landscape. Even more enigmatic is dark energy, the force driving the accelerated expansion of space. Unlike dark matter, it is not clustered in structures, but permeates all of space, pushing galaxies apart. In intergalactic voids, its effect is subtle yet inexorable, stretching distances and stretching light toward longer, redder wavelengths. It is an invisible agent dictating the ultimate fate of the universe, making darkness not just a visual phenomenon, but a dominant cosmic reality. Psychologically, encountering the concept of dark matter and dark energy reshapes our perception of emptiness. The void is not inert, it is dominated by unseen influences, vast in scale and mysterious in effect. For humans imagining the cosmos, it reveals a universe in which what is perceptible is only a small fraction, less than 5% of all that exists, and most of the reality around us is inaccessible to direct experience. Yet there is a meditative aspect to this hidden darkness. It underscores our limitations, encouraging humility and contemplation. The vast majority of the cosmos is invisible, indifferent, and unknowable directly, yet it shapes every observed phenomenon. This paradoxical interplay between seen and unseen, between the tangible and the hidden, transforms cosmic darkness from mere emptiness into a profound meditation on scale, existence, and perception. For explorers and scientists, dark matter and dark energy represent both challenge and opportunity. They demand instruments, calculations, and imagination. While human eyes perceive voids, telescopes, detectors, and models reveal the invisible structures dictating cosmic evolution. Darkness is no longer simply absence of light. It is a complex, active domain, full of forces and matter beyond perception, inviting reflection, study, and a sleepy awe at the hidden architecture of the universe. One of the most fascinating aspects of cosmic darkness is how light carries time across space. When we observe distant stars and galaxies, we are not seeing them as they are now, but as they were when the light first left them. The farther away an object is, the older the light reaching us. Looking at the Andromeda galaxy, 2.5 million light-years away, means seeing it as it was 2.5 million years ago, long before humans existed. In the outer reaches of the observable universe, this time, delay becomes profound. Galaxies billions of light-years away appear as they were, shortly after the Big Bang, mere hundreds of millions of years into cosmic history. Much of the universe we see is frozen in the distant past. The darkness surrounding these distant objects emphasizes the finite speed of light, the gaps between stars and galaxies, and the limits of human perception. Space is both vast and temporally layered. Psychologically, this creates a unique perspective. Observers must grasp that what is perceived visually is only a snapshot, separated by vast distances and unimaginable spans of time. The universe is not a single, accessible moment, but a collage of epochs, each point of light a messenger from the past. Darkness dominates because, at these scales, most regions have not yet transmitted light to our location, or their light has shifted beyond visibility due to cosmic redshift caused by the universe's expansion. This relationship between time, light, and darkness also highlights the transient nature of visible phenomena. Stars that shine today may have already burned out in the regions we observe. Galaxies may have merged, dissipated, or transformed since their light began its journey. Darkness is thus not just absence, it is a temporal veil, separating observers from the present state of distant cosmic objects. For astronauts and spacefarers, this principle is critical. Navigating, observing, and interpreting distant celestial bodies requires understanding that light is a messenger, delayed by millions or billions of years. Instruments extend perception beyond human eyes, capturing signals in infrared, X-ray, and radio wavelengths, revealing structures invisible to the naked eye. Even so, the majority of the universe remains dark and unseen, either beyond the cosmic horizon or hidden in wavelengths we cannot perceive. Ultimately, this interplay of time and light transforms the concept of darkness. The void between stars and galaxies is not static. It is a medium through which light travels slowly, revealing the universe's history incrementally. Observing these distant lights amid surrounding blackness fosters a contemplative awareness. We see the universe not as it is, but as it once was, a meditative, sleepy reflection on scale, time, and the inexorable march of cosmic evolution. Long before the first stars ignited, the universe entered a period known as the Cosmic Dark Ages. Approximately 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to combine into neutral hydrogen and helium. Light, previously scattered endlessly by free electrons, could finally travel freely. Yet there were no luminous objects, no stars, no galaxies, no quasars, only an expanding, cooling cloud of gas. This era represents the deepest darkness in cosmic history. To any observer, even with advanced instruments, the universe would appear nearly featureless. Photons from the cosmic microwave background, CMB, would still glow faintly, but the light was stretched by expansion into microwave wavelengths, invisible to human eyes. For millions of years, the cosmos was an unbroken expanse of darkness, punctuated only by quantum fluctuations that would later seed galaxy formation. Psychologically, imagining this epoch evokes profound stillness. There were no structures, no stars, no familiar reference points, only empty space filled with diffuse, invisible matter. The mind, accustomed to environmental cues and visual landmarks, encounters a universe devoid of orientation or scale. This primordial darkness is not merely a lack of illumination. It is a canvas upon which the first cosmic structures would eventually emerge. The eventual ignition of the first stars, population 3 stars, broke this long night. These massive, short-lived stars began to emit light, heat, and heavy elements into the surrounding void, marking the end of the cosmic dark ages and the beginning of the era of light. Their supernovae seeded space with carbon, oxygen, and other elements essential for planets and life, gradually transforming the universe from darkness into a structured, observable cosmos. For contemporary humans studying the Dark Ages, the lesson is both scientific and meditative. This primordial darkness illustrates that even seemingly empty space is dynamic and essential. The absence of light was a necessary precursor to the universe we observe today. Observing this epoch through instruments like the James Webb Space Telescope, which detects infrared light from the first galaxies, allows us to peer into a past defined by darkness, yet brimming with potential. The cosmic dark ages also remind us of the temporality of light. The universe has experienced cycles of illumination and darkness on a grand scale, with our current era being a fleeting period of relative brightness. Understanding this deep, primordial darkness provides perspective on human existence, the rarity of light, and the fragile, temporary nature of observable structures amidst the vast, eternal void. Darkness, in this sense, is both a beginning and a foundation for all cosmic evolution. After hundreds of millions of years in the cosmic dark ages, the first stars, known as population 3 stars, ignited, transforming the universe from an unbroken void into a landscape punctuated by light. These stars were enormous, often hundreds of times more massive than the Sun, burning at extreme temperatures and emitting intense ultraviolet radiation. Their emergence marked the end of the deepest cosmic darkness and the beginning of structure, chemistry, and illumination in the universe. The light from these first stars carried profound implications. For the first time, photons traveled through space, interacting with neutral hydrogen and helium, gradually ionizing the universe. This process allowed light to move freely across vast distances, creating the first observable patterns in the cosmos. Though invisible to human eyes today without sophisticated instruments, this era laid the foundation for galaxies, planetary systems, and eventually life. Psychologically, contemplating this transition evokes awe. For billions of years, the universe had been silent and dark. Then suddenly, energy burst forth, scattering into the void and transforming emptiness into a dynamic, glowing expanse. It was the universe's awakening, a reminder that darkness is not permanent and that even in vast emptiness, change and creation can emerge. For any mind imagining this period, there is a meditative, sleepy wonder in reflecting on the first sparks of cosmic light piercing an eternal night. These early stars lived fast and died young. Within millions of years, many exploded as supernovae, seeding the cosmos with heavier elements, carbon, oxygen, iron, and beyond. These explosions illuminated surrounding regions and initiated the complex chemistry necessary for planets and life. The contrast between the sudden brilliance of stellar ignition and the surrounding dark void was extreme, providing a natural lesson in the interplay of light and absence, a theme that continues throughout cosmic history. For human observers studying this era through modern telescopes, the first light represents a window into the universe's infancy. Infrared instruments, like the James Webb Space Telescope, detect galaxies formed from these initial stars, revealing structures that are faint, yet richly detailed. Even in regions that appear empty, there is evidence of light, formation, and energy, a reminder that darkness in the universe is often a stage for the emergence of brilliance. This period also teaches a broader lesson. Darkness and light coexist in a dynamic balance. The universe spends eons in quiet voids, only to be punctuated by intense bursts of energy and structure. For humans reflecting on the cosmos, the first light exemplifies the transient beauty of illumination within vast darkness, fostering a contemplative appreciation of the universe's scale, evolution, and the quiet, meditative rhythm of cosmic creation. As the first stars ignited and died, their remnants coalesced into larger structures, giving rise to the universe's earliest galaxies. These primordial galaxies, small and irregular at first, grew through mergers and accretion, forming luminous islands in a vast sea of darkness. For the first time, the cosmos displayed concentrated regions of light amid otherwise empty voids, a pattern that continues to define the universe today. These early galaxies emitted light primarily in the ultraviolet and visible spectra, but cosmic expansion stretched much of it into infrared wavelengths. Human eyes cannot perceive this light directly, yet telescopes sensitive to these wavelengths reveal galaxies teeming with star formation, hot gas, and swirling matter. Each galaxy represents a concentrated burst of illumination, a counterpoint to the surrounding darkness, demonstrating that light in the universe is both rare and precious. For observers imagining themselves among these ancient formations, the psychological impact is profound. Between each galaxy lies unbroken darkness spanning millions of light years. The mind struggles to reconcile the brilliance of galaxies with the overwhelming void between them. This contrast emphasizes both the isolation and the interconnectedness of cosmic structures. Galaxies are islands of light shaped by gravity, energy, and time, yet suspended within the emptiness of space. The emergence of galaxies also demonstrates the role of darkness in cosmic evolution. The voids between galaxies are not failures, they are essential. They allow gravitational forces to organize matter, prevent collapse of structures, and provide space for light to travel unimpeded. Darkness is not merely absence, it is a framework for creation, a stage on which luminous structures can appear, evolve, and interact. Astronomically, these early galaxies illuminate our understanding of time, scale, and evolution. Light from galaxies billions of light years away reaches us after traveling across deep cosmic voids, effectively showing snapshots of the universe in its formative stages. Observing this light offers a meditative glimpse into history, a reminder that the brightness we see is the product of countless processes unfolding over eons in a backdrop dominated by darkness. For humans contemplating the cosmos, the lesson is both visual and philosophical. The universe is mostly dark, yet it is punctuated by light, rare, structured, and transformative. Galaxies, stars, and emerging planetary systems remind us that darkness is not emptiness, but potential. In the contrast between void and illumination, observers can find a contemplative serenity, a quiet, sleepy awe at the delicate interplay of light and darkness that shapes the cosmos. Billions of years after the first galaxies emerged, the universe entered a period known as cosmic noon, the peak of star formation. Approximately 10 billion years ago, stars formed at rates far exceeding those seen today. Galaxies glowed with abundant light, nebulae radiated in brilliant colors, and cosmic structures became more complex and luminous than ever before. For a brief epoch, darkness was punctuated almost everywhere by active, bright regions, making this the universe's brightest era. During this period, galaxies were smaller, more irregular, and intensely active. Collisions and mergers sparked bursts of star formation, generating supernovae that illuminated the surrounding interstellar medium. Ultraviolet radiation from massive young stars ionized hydrogen clouds, creating luminous nebulae. From a cosmic perspective, this era transformed much of the universe from shadowed voids into vivid regions of energy, while vast stretches of intergalactic space remained profoundly dark. For humans observing from Earth, the light we detect from these galaxies represents a delayed history. Though these stars shone brilliantly billions of years ago, the vast distances mean that much of this energy is only now reaching us. The darkness surrounding these distant galaxies remains overwhelming. The cosmic voids continue to dominate most of space. Light is exceptional, confined to islands of creation amid a backdrop of emptiness. Psychologically, contemplating cosmic noon evokes both awe and serenity. The universe, at its brightest, still contains immense darkness. Human perception must grasp the rarity of illumination. For every radiant galaxy, millions of cubic light-years remain unlit. This interplay of light and void encourages reflection, a quiet, meditative awareness of scale, time, and the universe's vast, structured emptiness. The bright era also underscores the temporal nature of cosmic illumination. Star formation rates have declined steadily since the peak, meaning our current epoch is less luminous than the past. Eventually, star formation will wane further, and the universe will transition back toward darkness as gas reservoirs are depleted, stars die, and cosmic structures fade. Darkness, it seems, is the universe's default, with light as a temporary, fleeting exception. For explorers and observers, cosmic noon offers a contemplative lesson. The universe's beauty is ephemeral, and light is precious. The contrast between luminous galaxies and the surrounding void emphasizes the meditative serenity of space, the rarity of visibility, and the essential role of darkness as the backdrop against which all cosmic illumination is defined. In this balance, humans can experience awe, quiet reflection, and a sleepy sense of connection to the vast, evolving cosmos. As the universe ages, the bright era of prolific star formation gradually declines. Gas reservoirs within galaxies, fuel for new stars, become exhausted or dispersed by supernovae and galactic winds. Star formation rates drop, and the once luminous cosmos slowly dims. Galaxies that once blazed with activity now contain aging stars, white dwarfs, and remnants of past brilliance, while the vast intergalactic voids remain black and empty. The decline of stellar activity marks the universe's slow return to darkness. Massive stars explode as supernovae, leaving behind neutron stars or black holes. Medium-sized stars like our Sun exhaust their fuel and cool into white dwarfs. Small, long-lived stars continue burning for trillions of years, but their light is insufficient to illuminate the universe broadly. Across billions of light years, darkness becomes the dominant state once again. Psychologically, envisioning this gradual dimming evokes a sense of quiet melancholy. The cosmos, once punctuated by bright nebulae and star-forming galaxies, transitions toward a calm, shadowed expanse. Human minds, accustomed to the immediacy of visible light, must imagine a universe where illumination is rare, isolated, and transient. The contrast between surviving light sources and the surrounding void highlights the ephemeral nature of cosmic brilliance. Even in this era, light persists in localized regions. Collisions between white dwarfs can trigger supernovae. Black holes occasionally accrete matter, emitting X-rays and high-energy radiation. These rare events are isolated bursts of light against a backdrop of darkness, much like a single candle in a vast, silent hall. Observers in space would witness pockets of activity, while the majority of the universe remains profoundly black. For humans, this cosmic transition underscores an essential truth. Darkness is not failure, but the universe's natural state. Light emerges temporarily, structured and exceptional, while darkness dominates on scales far beyond earthly perception. Understanding this cycle fosters a meditative appreciation of impermanence, scale, and the dynamic balance of illumination and void. Ultimately, the universe's slow fade into darkness is both inevitable and contemplative. It reminds us that light is rare and precious, that cosmic brilliance is temporary, and that most of existence lies in quiet emptiness. For humans observing or imagining this era, there is a subtle, sleepy serenity in reflecting on the universe's return to darkness, a reminder of our small place within an immense, evolving, and profoundly silent cosmos. Looking far into the future, the universe approaches its ultimate fate, the heat death. Over trillions of years, stars will exhaust their fuel, galaxies will lose the ability to form new stars, and existing stars will cool into white dwarfs, then black dwarfs. Black holes, once massive and dominant, will slowly evaporate via Hawking radiation, leaving only diffuse particles and photons drifting through an ever-expanding void. In this final state, light will become exceedingly rare. The universe will be an expansive, cold, dark expanse, where temperature approaches absolute zero and no energetic processes remain to illuminate the cosmos. Cosmic structures, once vibrant and observable, will fade into faint, unresolvable remnants. Darkness will dominate in every direction, eternal and unbroken. Psychologically, imagining this state stretches human cognition. The void is not just a visual absence, but a complete cessation of energetic activity. There are no stars, no planets, no galaxies, only space itself, expanded, silent, and unchanging. The mind struggles to comprehend both the scale and permanence of this emptiness. Yet paradoxically, it also evokes a kind of meditative calm. The universe, stripped of distraction and fluctuation, exists in perfect stillness, inviting quiet reflection on time, impermanence, and our own fleeting existence. Even in this extreme darkness, physics continues its subtle work. Particles drift, quantum fluctuations persist, and residual radiation from the early universe lingers, albeit spread thinly across expanding space. While imperceptible to human senses, these remnants testify that even in the deepest void, the universe maintains structure and activity at scales far beyond perception. For humanity, contemplating the heat death highlights the temporary nature of all cosmic light. Stars, galaxies, and civilizations are ephemeral bursts within the vast darkness that is the default state of the universe. This understanding fosters perspective. Our existence, our light, and our consciousness are fleeting yet remarkable within a cosmos defined by silent, eternal darkness. Yet even as the universe succumbs to cold, absolute darkness, the lesson is profound. Darkness is not a void to fear. It is the backdrop against which life, light, and awareness emerge. For explorers, scientists, and dreamers, this ultimate darkness encourages contemplation, curiosity, and a sleepy serenity, a recognition that meaning and wonder exist not in the permanence of light, but in our ability to perceive, create, and reflect within the infinite, silent, and dark cosmos. As we close this journey through the universe's deepest darkness, take a moment to reflect. From the faint glow of distant stars to the absolute void between galaxies, from the sudden nightfall on the moon to the eternal cold of the heat death, darkness is the defining backdrop of our cosmos. It is not evil, not hostile, merely vast, indifferent, and infinite. Yet within this darkness, we find meaning. Human curiosity, exploration, and imagination create light, literally and metaphorically, against the void. Our spacecraft, our telescopes, our observations, and our stories illuminate the darkness, transforming empty space into a canvas of discovery, reflection, and wonder. The universe reminds us of our place, small, temporary, and fleeting, but capable of insight, creation, and awe. Darkness is the stage, and we are the observers, thinkers, and explorers who bring perception, meaning, and imagination to the void. So when you look up at the night sky, remember, the darkness you see is not emptiness. It is a vast, quiet invitation to explore, to reflect, and to dream. And as you drift into sleep tonight, let the universe's calm, profound darkness remind you that even in the quiet void, there is beauty, wonder, and possibility. Thank you for joining me on this journey through the cosmos. If this exploration brought you awe, calm, or curiosity, consider liking the video and subscribing to Sleepy Universe Zone. Together, we'll continue to explore the universe, finding light, wonder, and sleepy serenity within the darkness. Good night, and may your dreams travel among the stars, across the cosmic void, and through the quiet, endless beauty of space.